full-on coding for pseudo-simulating hazardous environments involving the Bose-Einstein condensate. How about we go meet my assistants? Ah, here they are. This is our intelligent lab gorilla, Killian, and my lovely graduate student, Michael.
I was just reviewing my research that I've done of calculus and chemistry. For example, half-life. It follows differential equations by the rule y is equal to c, a constant, times e to the power of kt. This is what we call exponential decay. It describes how you have a substance that decays over time from its original amount to a different amount.
Thanks, Michael. We were also working on Bernoulli's principle, a fundamental principle of nature that calculus helps us derive using 1/2 mv squared.
Entropy is a measure of the disorder in the universe or in a closed system, and sometimes if a diamond is perfect as ours, you can have zero entropy because there's absolutely no disorder.
Thanks, Killian. That's quite enough. We're going to move on to the ideal gas law now, which is PV equals nRT. Our good friends at the Magnolia Calculus Department have derived R for us.
Speaking of gases, if I may interrupt, Doctor, when you have a gas that moves into a vacuum, it can be demonstrated by square root of m2 over square root of m1, which is the derivative of the rate of diffusion for gas 1, or the derivative or rate of the gas 2. Diffusion, coming on from heat fusion, is
diffusion is actually the rate or distance traveled by particle 1 over the distance traveled by particle 2. And that's represented by the same equation, the square root of m1 over the square root of m2. And here we have some NO2 particles colliding with some hydrochloric acid particles to form a white precipitate.
Thanks, Killian. We're going to move on to oxidation states now, which is the state of nature where positive and negative charges on atoms cancel each other out to remain neutral. Speaking of such, we can go on to balancing equations, where we use this state to predict products of an equation knowing only the ingredients.
Doctor, I think I need to talk about rate law. It's very important in the world of calculus and chemistry. Rate law is just a matter of how things go into each other, such as the rate at which the reaction proceeds minus the rate at which it regresses is, in essence, the rate law.
Well, thanks for that information, Michael. I think I'm going to talk about concentration now. Concentration is the integral of the K, or constant, times the product to the power of its coefficient. Thermochemistry is the measurement of the temperature released in a closed system and in the equation, or the reaction. That's measured by Q, the energy in joules, equal to the mass times the heat constant times the change in temperature. Now, aqueous equilibrium.
I'll talk about this one, Killian. Aqueous equilibrium is really quite simple. All you do is take the integral of the products and divide it by the integral of the reactants. That's all there really is to it.
Thanks, guys. That was helpful. As it is very clear, calculus is very essential in chemistry, and if you ever want to be in a chemistry lab later in your life, you better brush up on your calculus. That graduate student of mine.